It was an extremely hot day. In order to cool down, you tried to turn on the fan, but suddenly realized that it wasn't working. Then you began curious about how the fan works. For a start, the center of the blade is connected to a motor, which is driven by electricity. Inside the motor, there's a big magnet. The wires in the motor can be magnetized by electricity and create magnetic field. Constantly changing the direction of the magnetic field, we can create a steady force and make our blade work normally. But how in the world can the wires be magnetized by electricity? The main reason can be credited to a famous theorem, special theory of relativity. It may sound complicated, but look at this electrical neutral wire. There are particles in the wire, which are the positive charge protons and the negative charge electrons. When we plug in electricity, the electrons will be moved because of the momentum given by the alternating current. To keep the wire electrically neutral, the space between the protons must be exactly the same as the electrons. But the electrons are now moving. If there's a negative charge onion moving the same direction as the electrons, in our frame of reference, neutral wire and onion shouldn't affect each other. However, in onion's frame of reference, electrons move slower than the protons, which means the space between the protons would decrease. At the same time, because of the electrons are moving the same direction as onion, they will become more spread out, causes the wire to become positively charged and attract onion. This phenomenon is called length contraction. And guess what? Velocity affects not only your length, but also your time. According to Newton's law, if there is relative velocity between the observer and the observed, the velocity of the observed that the observer sees will change. But today, when a train approaches, you, standing at the platform observing the train, won't notice the velocity of the headlight changing. In fact, you'll see the light as normal. The fact seriously overthrew the idea of classical physics, so the scientists decided to state hypotheses. The second hypothesis besides length contraction is constant speed of light. To maintain the speed of light, your time has to be slower than the captain's. That's right, the time depends on how fast you are. Which means when you run on a track very fast approaching the speed of light, for a while, you might find out the friend who is waiting for you has grown long white beard, which didn't happen to you. As you can see, the universe isn't as simple as we used to think. Stay hungry, stay foolish. Thanks for watching.